Want to know how to easily set up HTTPS on a web application deployed with Kamal? Keep watching to learn how. Deploying web applications using Kamal is pretty easy once you have everything set up with your infrastructure and your app. All it takes is a single command and your application will be up and running on the servers of your choosing. However, Kamal still doesn't handle everything that you need to set up for a modern web application. One of the glaring omissions that you need to deal with on your own is setting up HTTPS for secure communication between the user and your application. In a previous video on this channel, I explained how to set up HTTPS on a load balancer. But in many instances, you have your entire application deployed on a single server which doesn't need a load balancer. While there's no specific configuration settings to get your app working with HTTPS, there are ways you can get your Kamal deployed applications to use secure HTTPS connections. A common way to do this is using a service like Cloudflare to proxy your domain through a secure connection. You can use their DNS service to point to your server, first going through Cloudflare via HTTPS and then having Cloudflare pass the connection along to your server. But this isn't a fully secure solution, as it only encrypts connections from the browser to Cloudflare, and it doesn't encrypt the connection between Cloudflare and the server hosting your website, so you'll still need to handle that on your end by getting an SSL certificate. These days, getting an SSL certificate is dead simple thanks to Let's Encrypt, and we can easily set up our Kamal configuration to use Let's Encrypt and automatically secure connections to our server. Let's see how we can do that. For this video, I'll use a web application that I've already deployed with Kamal called Airport Gap. I've been using this app as an example for other Kamal related videos on this channel, so go check those out if you want to see the deployment process from the beginning. While deploying the application using Kamal works well, by default, it only works through non-secure HTTP connections. So I can access the app through HTTP at the domain, which is demo.airportgap.com. So this loads correctly, but as we see here, the connection is not secure right now. But if I go visit the site on the HTTPS version, we'll see that it won't work with Kamal. So let's fix that right now. All the heavy lifting for this process will be handled by Traefik, which is a reverse proxy service Kamal uses for routing connections to the app running in your Docker container. One of the cool features that Traefik provides for running apps through Docker containers is using labels to configure its behavior. When running a Docker container, you can specify a label as a key value pair with metadata. Traefik watches those container level labels to configure its routing settings like forwarding requests based on the host name, specifying custom ports, and more. Kamal sets up a few default labels on deployed application containers, but we can also modify these labels along with Traefik's configuration for added functionality. To set up SSL connectivity, Traefik already has built-in support to automatically generate Let's Encrypt certificates and set up our web application to use HTTPS through labels. Let's update the existing Kamal configuration to generate a certificate and set up HTTPS connectivity automatically. First, let's configure Traefik to begin accepting HTTPS traffic and set things up for the Let's Encrypt certificate generation. To do that, we'll create a new Traefik section at the end of our Kamal configuration file, which allows us to configure additional options and arguments. Note that this is a root level key for the YAML configuration file, so be mindful of indentation when setting this up. Under the Traefik key, we'll set up the options setting. Kamal sets up Traefik using Docker, and the configuration under options are passed as additional arguments to the docker run command that Kamal executes under the hood. This allows us to start the Traefik proxy with a few additional settings. First, we'll want to tell Traefik to accept requests on port 443 for secure HTTPS connections. In Docker, we can do that with the publish argument and mapping a port on the server to a port on the container. We can map multiple ports here, but we only want to map port 443 from the server to port 443 on the container like this. Another thing we need to do is to mount a file from the host server to the container using the volume argument. We'll use this to store the data that Let's Encrypt uses to set up the SSL certificate for our application. Using a volume means that the files Let's Encrypt needs will remain on the server, and we won't have to worry about losing the SSL certificate if the web application container is shut down. Again, we can mount multiple volumes here, but we only need one. The location of the volume on both the host server and the Traefik container doesn't matter as long as it's a valid path to a file. The file that Let's Encrypt needs is a JSON file. In this example, I'll mount a file from the host server called etc let's encrypt /acme.json. And I'll use the same location to map it inside the container. Before going any further, the acme.json file must exist on the server first at this exact location before we attempt to mount it in the Traefik container. This step doesn't happen automatically, so we'll need to do this manually or by using a configuration management tool like Ansible. I'll do this manually by logging into the server through SSH. First, I'll make sure that the Let's Encrypt directory is created. And then I'll create a blank acme.json file inside of the Let's Encrypt directory. Once that's created, it's very important to set the correct permissions on the acme.json file that we just created. Otherwise, the SSL certificate generation process will fail if the permissions are too open or too restrictive. Let's Encrypt needs the file to have read and write permissions only for the file's owner. To do that, we'll use chmod 600 on the file we just created. And let's make sure that the permissions are set correctly before we proceed. And it seems like it is. So we're done setting up arguments for running the Traefik Docker container. Now we'll need to configure Traefik using the arg setting under Traefik. And in this section, we'll configure Traefik to accept and redirect all requests to HTTPS and configure the built-in Let's Encrypt configuration to generate an SSL certificate automatically. First up, we'll begin configuring Traefik's entry points. An entry point defines the ports that Traefik will open up to accept requests. By default, Kamal doesn't set up any entry points and uses port 80 as a catch-all entry point to the web application. We'll have to explicitly set this entry point in our configuration alongside another entry point to port 443 for secure HTTPS connections. The first argument we'll set up here is the EntryPoints.web.address key. The web segment here is the name of our entry point, and you can use any name for it. And address tells Traefik the port we want to configure for this entry point. We'll use this argument for accepting requests at port 80 on the server. The value for this argument is the host and the port that we want as an entry point. We don't need to specify the host, but we do need the port, so we can set the value here to :80. The colon is important so Traefik knows to accept requests for any host on our server. We'll set another entry point using the EntryPoints.WebSecure.address argument. This is similar to the previous entry with a different name for the entry point, which in this case is WebSecure. The value for this will be :443. This will allow requests to port 443 on our server. These two arguments open up Traefik to receive requests to these ports, but we eventually want to have our non-secure HTTP requests redirected to secure HTTPS connections. We can configure the web entry point in Traefik to do this with a couple of arguments. First, we'll add an argument to redirect the request from the web entry point to the web secure entry point. This argument starts with EntryPoints.web, which is the name of the non-secure entry point. Then we'll follow it up with HTTP, which is for HTTP protocol related configuration on the entry point. Next is redirections to indicate that we'll configure a redirect. We want to redirect from one entry point to another, so we'll use the entry point argument next to indicate this. Finally, we need to specify where to redirect to these requests using the to argument. So we'll end up with this long string to indicate that we want to have a redirection on this particular entry point. The value for this argument is the name of the entry point for redirection. So since we called our secure HTTPS entry point earlier as web secure, that's the value that goes here. The next argument we'll set is to tell Traefik that this redirection target should change the HTTP scheme to HTTPS so it handles the transition automatically for us. We can do that with the argument entrypoints.web.http.redirections.entrypoint.scheme. One thing to note is that the entry point here and here, the case does matter, so make sure that you're using a capital P for the point and not a lowercase p. The value we'll use here is HTTPS, which indicates that we want to redirect from HTTP to HTTPS. Finally, the last redirection argument we want to set is entrypoints.web.http.redirections.entrypoint.permanent. We're using this argument so if a client makes a request to the non-secure HTTP endpoint, Traefik will return a 308 permanent redirect status code, which helps search engines and other clients know to use the secure endpoint moving forward. This argument accepts a Boolean value, so we'll just set it to true. We're now done configuring Traefik's entry points. Now it's time to configure Traefik to use Let's Encrypt to generate an SSL certificate for our application, which we can do also through arguments. These arguments have the prefix of certificates resolvers.let'sencrypt.acme, indicating that we'll use Let's Encrypt's automated certificate management environment or ACME protocol. The first one we'll set up is the email argument to indicate which email address to register for generating the certificate. This is a required argument, and it's important to set a valid email address so you can receive notifications about expiring certificates and other important messages. I'll set my email address here. Next, we'll set up the certificates resolvers.let'sencrypt.acme.storage argument. This argument is the file that Let's Encrypt will use to store the information about the generated certificate. Remember the volume we set up earlier in the options section of the Traefik configuration? Here's where we're going to put that to use. The value here is the same file that we'll mount in the Traefik Docker container. So we'll copy the path and the file name here, and we'll paste it as the value of it. It's important that the file is in the same location as the volume and that it was created and set up with the proper permissions on the server as I showed earlier. After setting the email and the storage path, we'll need to configure the Let's Encrypt ACME challenge so it knows we control this domain and server. Let's Encrypt has different types of challenges, but the easiest and most automated way to handle this is with the HTTP challenge. So the argument will be certificates resolvers.let'sencrypt.acme.http challenge. This challenge requires that a specific URL for your domain exists with a token and a thumbprint of your account key. By setting this argument to true, Traefik automatically handles setting up this route and the contents of the file for you, so you won't have to do anything for this challenge. Finally, we'll have one more certificates resolvers argument for the Let's Encrypt HTTP challenge called EntryPoint. This tells Traefik which entry point it should use when making the request to the special URL for the challenge. We'll need to send our request to the web entry point, since it's the only entry point we're going to have accessible before the SSL certificate process is completed. And with that, we've configured our Kamal backed Traefik instance to handle requests to port 80 and 443, redirect non-secure HTTP requests to secure HTTPS, and configured the built-in Let's Encrypt provider to generate an SSL certificate for us. This configuration handles the routing for Traefik, but we still need to configure our application to generate an SSL certificate for its domain and use the web secure entry point for connections to the host. To do that, we can modify the labels on our web application container, which Traefik will then use to change how it routes traffic to the service. We'll go to the servers section on our configuration, and under the web role for our application, we'll create a new key called labels. This lets us add additional labels to our application container. Labels related to traffic routing in Docker are strings prefixed with traffic.http.routers. The next segment of this label is the name of the router for traffic. In Traefik, routers handle any incoming requests, processes them according to your configuration, and eventually passes the request to a service, in this case, our web application. The name we use here for the router doesn't matter as long as it's unique, and we use the same one consistently where relevant in our configuration. I'll name this router as Airport Gap to match the application name. For this first router label, we'll configure the rule setting for this route. This label helps Traefik figure out which configuration to use for a given router according to what it matches. For example, we can have a router with a rule that matches requests to www.domain.com, which passes the request to a web application service, while another router contains a rule matching requests to api.domain.com, which passes the request to a separate API service. You can specify a rule by the request's hostname, path, headers, and many other matchers, along with combining them to create more specific routing rules when needed. Check out Traefik's documentation for more details. To keep it simple for this example, I'll set a rule to match any requests made to the hostname demo.airportgap.com. So the value for this label will be host with a capital H, opening parentheses, and then in between backticks, the name of the domain, which is airportgap.com. It's important to note that when setting up a rule definition like this one in Traefik, you'll need to use backticks and not single quotation marks. It's something to keep in mind when working with router rules in Traefik. The next label I'll set is the traffic.http.routers.airportgap.EntryPoints, which specifies the entry point to allow for this router. We defined two entry points earlier in Traefik called web for requests to port 80 and web secure for requests to port 443. Since we want to use secure HTTPS connections, we'll use the web secure entry point here as the value for this label. Finally, we'll need to set up a label to tell Traefik that the Airport Gap router will use a certificate resolver to trigger an SSL certificate generation challenge if needed. The label for this is traffic.http.routers.airportgap.tls.cert.resolver. And the value for this will be the built-in Let's Encrypt resolver. Setting this label up tells Traefik to handle all of the Let's Encrypt complexities for us. The first time a request is made to this router, Traefik will notice there's no SSL certificate for it and proceeds to use Let's Encrypt to generate one that lasts 90 days. After a successful certificate generation, Traefik will automatically track the expiration date for it and attempt to renew the certificate 30 days before it expires. If everything is set up correctly, you won't have to worry about expiring certificates, which is pretty cool. So to recap, these labels for the web application create a new traffic router that matches requests made to the demo.airportgap.com host. And then Traefik will listen to the web secure entry point, which is on port 443, and then use the built-in Let's Encrypt certificate resolver to generate an SSL certificate if needed. Our Kamal configuration is now all set up to generate an SSL certificate automatically on a single web host. Let's get that going. First, we'll need to reboot the Traefik instance running on the server so it runs with the new configuration we set up for it. We can reboot the instance with Kamal Traefik reboot, which will give us a warning about having a brief outage while Kamal stops the container, removes the old one, and starts a new one. Since this is for a demo, let's say yes. If everything is set up correctly, the container should reload successfully after just a few seconds. And if you see the Docker run command that Kamal executed on the server, you'll be able to see all the options and the arguments that we set up, like the redirections, entry points, the certificate resolvers, and more. So it looks like our configuration is already set up and ready to go. Now we'll need to reboot the web application container so it can set up all the new labels we configured. We can do that with Kamal app boot and limiting the scope of the web role using the rows flag and setting it to web. For some reason, there's no Kamal app reboot command, so this might be confusing, but the Kamal app boot command pretty much does the same thing as we did with Traefik, where it stops and replaces the container with our current configuration. Once the application is restarted, we should now be able to reach the application through HTTPS. So now if I attempt to go to the secure HTTPS version of this application, we can see that it loads without any issues and we have a secure site right now. If we log into the server again through SSH and open the file that we mounted at etc.let'sencrypt.acme.json, we'll now see that it has all the information for the certificate from Let's Encrypt. And this file is mounted inside of the Traefik Docker container. So Traefik already has all this information and it will continue to use it for the secure HTTPS connections. With just a couple of updates to your Kamal configuration, you'll have end-to-end encryption between the user and your web application. The Traefik reverse proxy service that Kamal uses to route requests to your app has all you need to generate an SSL certificate through Let's Encrypt and renew it automatically. While it's not as simple as toggling a setting in Kamal, the process is easy enough to get working quickly once you know how to configure things. Hopefully, this video taught you how to do it for your own applications. As always, if you found this video helpful, consider subscribing to this channel for more tips on helping developers ship their code confidently, from development to deployment. You can also check my website for more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thanks for watching, and I'll see you in the next video.